Good morning, good afternoon, good evening. In this webinar, I will be covering interoperable standards relevant to monitoring energy in network lighting systems. So the standards we want to cover play very nicely together for a complete solution. They all are related to energy efficiency, which has been the key driver behind the widespread adoption of networked lighting control systems. There are multiple standards for energy monitoring, and each is covering part of the whole solution. So the first one we'll cover is the DALI part 252, which defines energy-related capabilities of LED drivers. Then we have DALI part 341, which defines the translation between DALI data and Bluetooth mesh data. And then last but not least is the ANSI C137.5, which defines performance requirements for devices reporting energy data. As I said, the standards place nicely together for a unified, fully interoperable experience. Right, so the first one is the DALI part 252, which is applicable to LED drivers. And as you probably know, DALI stands for Digital Addressable Lighting Interface, and it covers many aspects of lighting control. And DALI standards are organized in so-called parts, and part 252 defines how LED drivers measure and report energy-related data. So the DALI part 252 defines driver-related memory banks. These are memory locations where the particular data values are stored. These memory banks are related to dynamic power and energy data. And what's interesting, they cover both input and the load side. So you can basically report values that include or exclude the driver itself. What's important to mention that a device, a driver which is compliant with part 252 can act as the ANSI C137.5 energy monitoring device. We'll get into the ANSI C137.5 details in a moment, but just bear in mind that those two are acting together. So DALI defines how this is organized, and the ANSI standard defines the performance requirements. So looking deeper into what part 252 offers, it offers a number of values that can be read from the driver, and the most important value for energy measurement is, of course, the active energy, which is reported in watt hours. We also have here instantaneous values like active power, apparent energy, apparent power, and the same for the load side of the driver. So you can read real time how many watts given luminaire is consuming at a given point in time. Now, this part 341, it defines the interaction between the DALI bus, what happens on the DALI bus, and the wireless Bluetooth mesh network. So the part 341, it is a standard that came from the joint collaboration between the DALI Alliance and the Bluetooth SIG, and it effectively defines the mappings between Bluetooth mesh and DALI. So in this sketch here, you can see the principles of how it works. So basically we have a DALI driver, which of course is supplied with a line voltage, and then it has an LED output line which is connected to the light source. And then it also has two connectors for the DALI bus. They are typically marked DA plus and DA minus, although the DALI bus is polarity free, so you don't need to worry about mapping of those two connectors. What is also very important is since the introduction of the DALI 2 standard, the DALI bus can provide power to other devices. So, for example, here I have a Bluetooth mesh node, which is a small sensor-like device. It may, of course, include sensors. It connects over the DALI bus to the driver, and it's also powered from the driver over this same DALI bus. So you see, it's only two wires connecting this Bluetooth wireless node to the driver. Now, what the DALI part 341 defines, it defines how those values available or defined on the DALI side, how they map to Bluetooth mesh values, also referred to as Bluetooth properties, such that any Bluetooth system can understand this data coming or sourced from the DALI devices. At the bottom here, you can see an illustration of an actual device. So the DALI part 341 specification refers to them as gateways, but don't be confused by the name. It's not like a big system gateway. This is simply a gateway between what's inside a luminaire, like the drivers, there may be one or more, and the outside intra-luminaire network, which in this particular case is Bluetooth mesh. And this device may include sensors like ambient light and occupancy. They provide additional functionality, and it also acts as a controller for the driver. So actually all the logic about occupancy, vacancy, daylight harvesting, dimming, manual overrides, it all happens inside that device, and then it commands the driver over the DALI bus what to do, and on the other hand it retrieves data from the driver over the DALI bus and then rebroadcasts it over Bluetooth mesh network. So what's important here that the DALI bus is a bi-directional interface, so this gateway device can act as a controller, commanding the driver with commands like dim up, dim down, turn on, turn off, and it also can collect data from the driver itself. And the third standard that is relevant as far as we consider energy for lighting devices is the recently introduced ANSI C137.5. As you can see, it has been published quite recently. Actually, the date is August 5, 2021, so it's very recent. Here is the link to the standard document, and what's important, it doesn't say how these connections occur or what kinds of data is flowing there, because there may be many solutions capable of doing that. It reports so-called performance requirements. So things like how precise this data has to be, what are the aggregates, like it mandates collecting data in 15-minute buckets, such that the collective data representing the entire system can be interchangeable. So systems that consume this data can expect this data coming in a well standardized and understandable format, as well as it trusts the values, because the ANSI standard defines how precise, how accurate they have to be, what's the potential error in this reported values, and similar related performance requirements. So looking at the complete system architecture, this is how it may look like. So if we go in this illustration from the left side, we have the light source, then we have the driver, and then we have the DALI bus, the two wires connecting the driver to the wireless node. And all those three components, they basically sit inside a luminaire. So we call it an intra-luminaire setup or intra-luminaire network, which is handled by the DALI connection. Now, luminaires, each luminaire internally looks like here. Of course, there may be multiple drivers, there may be multiple light sources, but in principle, those three types of components are inside each luminaire. Then, because the wireless nodes can form a wireless mesh network, those luminaires interact together, so they can be grouped such that they respond synchronously to some events like occupancy, for example, or they dim up or down depending on the ambient light level that is required in a particular zone. And this mesh network, this is covered by Bluetooth specifications. It may connect in the end to a device that is a cloud gateway. So the function of the cloud gateway is to collect data from the entire mesh network. So each luminaire here reports its own data, and through the mesh network, this data flows to the gateway, and then the cloud gateway forwards this data to a cloud service, which stores the data and provides the source for presentation dashboards. So from a system categorization perspective, you may say that those first three components, this is the luminaire, then we have the mesh network and cloud connection subsystem, and then we have energy monitoring services, which are mostly cloud-based with the cloud storage and presentation dashboard. And of course, there also can be a possibility of downloading the data, for example, in a spreadsheet format for further analysis or for forwarding this energy consumption results to a third party. Now, from the standard perspective, what's inside the luminaire, as I explained on the previous slides, this is covered mostly by the DALI, in this particular case, parts 252, which is energy metering and energy measurement, and 341, which is translation of DALI to Bluetooth mesh. Now, the interluminaire network, this is covered by the Bluetooth standards. In this particular case, these are Bluetooth mesh profile and models. And then we have a variety of cloud-based ecosystems. So the cloud ecosystems, I don't mention any standards here because they are internet standards. Each ecosystem has its own organization. What's important that we are really interested about standardizing things up until this gateway device, because then it's all about this gateway can connect to this or another cloud ecosystem. Now, the yellow color bars at the very bottom, they represent the nomenclature as it is used in the ANSI C137.5 standard, which I mentioned relates to performance requirements. So two important things to mention here. The ANSI standard defines so-called ERD, or an energy reporting device, and in our case this is a luminaire, And then it defines the EDC, which is energy data collector. And the data collector is the network together with the gateway and simply the whole rules that define how this data is collected, how frequently, how much data can be missing, what to do with the missing data points, and so on and so on. So the role of the ANSI standard is to govern, I would say, the quality of this energy data. Now, this is what I would say the default architecture, because you can use for each of these elements here, you can use off-the-shelf components. You can use off-the-shelf light source and then off-the-shelf DALI driver with energy metering part 252 support. And then you can use off-the-shelf DALI to Bluetooth wireless node and then build Bluetooth mesh network out of these. Now, you may ask, what if I don't have a DALI driver, or what if I don't use a DALI driver? All is not lost, and actually there is quite a nice alternative to this setup. So you may be looking on the market for integrated Bluetooth drivers. And this is a growing category. Of course, at this point, because DALI has been around for many years, there is a broader selection of DALI drivers than integrated Bluetooth drivers. But of course, if you find an integrated Bluetooth driver, it may very well serve the purpose, and it even simplifies the system because the driver does the energy monitoring and reporting by itself. It doesn't need any other connection. So you see that the driver here represents a luminaire as a part of this wireless Bluetooth network. Everything else is like on the previous slide. So we have the reporting device, which is the luminaire that includes the wireless driver and the light source, and then we have energy data collection network together with the cloud gateway. Now, if you don't have or don't like a particular Bluetooth mesh driver, then there is yet another interesting alternative that will also work. So many of you are familiar or have been using so-called analog dimmable driver, which are controlled by a 0 to 10 volt line. And as you may know, this connection is in one direction. So the wireless bridge is a device that outputs 0 to 10 voltage and controls the driver over this 0 to 10 line. It can only command the driver over that line. It is not capable of reading anything from the driver because it's analog one-directional connection. So you may ask, okay, so how it's possible in such setup to measure and report energy? And actually, it's very possible. It's very possible when you know so-called energy profile of a particular luminaire. So the way it works is that the energy usage is based on real-time information on the dim level of the luminaire and on the luminaire energy profile. So what is this luminaire energy profile? This is something that needs to be done for each particular luminaire setup. So by that I mean a driver together with light sources, and basically you measure, and that measurement needs to be done only once. You measure a couple of reference points. So here, as an example, we have 11 reference points, which at different dim levels, we have measured the actual wattage that is consumed by this particular luminaire. So at 0% dim, it consumes 2 watts. That may sound weird here, but it really shouldn't, because there is some standby consumption. Actually, in this case, it's fairly high, but nevertheless, it just represents the idea that at 100% it's 40 watts, and anything in between, it's typically a linear relationship between the light level or dim level and the wattage. So this measurement of reference points has to be done using a good power meter. And those data points need to be entered into the application that collects and reports the energy data. And if this application, such as in this example here, allows for inputting such energy profile, then you can collect these reference points and then make sure that you collect them from not just one unit. Just do it over a couple of units, because there will be slight differences, and you want to capture something that represents a good average. To learn more about this method and how it can be used, Silvair has released the application note, which is the SN-206. Calculated energy monitoring, and it discusses the methodology of profiling a luminaire, as well as potential deviations or inaccuracies in reported data. By that I mean how much accurate or inaccurate the reports can be, and whether they fall into what is required by the performance standards or by the organizations that want these reports to be presented to them. So by all means, this method can be very accurate, and although it may sound a little bit strange, this is actually a method quite similar to what the energy reporting drivers do themselves internally. So a driver, like a DALI driver with energy with energy reporting functionality built in, it actually does not have an energy meter built in. The way a driver reports energy is it simply knows what it's outputting to the light source. It knows the voltage, it knows the current. Each driver today has a microcontroller, so that microcontroller in the driver can collect those voltage and current data points, multiply them, and report as consumed watt hours. So this method actually, as long as you do the profiling quite precisely, is very accurate and does not end up with overall data which is more inaccurate than any of the other methods. So this is a very interesting alternative, which I believe can cover or can help covering situations when the data is not available from the driver itself, like in the previous two examples. So finally, a few words about what happens when we have collected this data. So this data, typically it goes to a cloud system, and then it can either be visualized on a dashboard, like we have an example here, and depending on the functionality of these dashboards, you can observe the energy consumption by devices in different slices, different time periods, or different areas or zones. You can visualize them in a form of heat maps, like it is exemplified here, or you can download this data to a spreadsheet, and that spreadsheet can be used to further analyze the data or to provide the energy consumption report to an organization that needs that. Like, for example, when you have a network lighting control system which took advantage of rebates, then probably your utility would like to see regularly the energy data coming from your system, and this is where either the dashboard can be used or it can be downloaded as a file for further processing. So that's about it. Thank you very much for listening.